Solve the absolute value of 2x plus 3 equals the absolute value of 4x minus 3. This one is more complicated than the previous problems because there are two absolute value symbols instead of just one. Well, two sets of absolute value symbols instead of just one set. However, the strategy that we're going to use is actually very similar to the strategy that we've been using. Now, if we have the absolute value of one expression equal to the absolute value of another expression, if we have two expressions that have the same absolute value, then there are two possible situations that could give us solutions. The first is if those expressions are equal. If 2x plus 3 happens to be equal to 4x minus 3, we don't know what the value of those expressions is, but if they're both equal to each other, that means that when we take the absolute value of each of them, the absolute values are equal to each other. For example, if both of these were equal to 5, then we'd have the absolute value of 5 equals the absolute value of 5, which is true. If both of these were 12, then we'd have the absolute value of 12 equals the absolute value of 12. We don't know what their values are, but we know that if they're equal to each other, then automatically the absolute values are also equal to each other. There's one other scenario where we could have these expressions having equal absolute values, and that scenario is that if one of the expressions, 2x plus 3, is equal to the opposite of the other expression, 4x minus 3. If these two expressions are opposites of each other, like 5 and negative 5 or 12 and negative 12, then we know they'll have the same absolute value. The absolute value of 5 is the same as the absolute value of negative 5. The absolute value of 12 is the same as the absolute value of negative 12. Now, we don't know what these values are, so we can't actually set both of them equal to 5 or something like that. That's not going to work. But we do know that we will end up having a true equation if those expressions are equal to each other, or if one of the expressions is equal to the opposite of the other. So that's how we split things up. And you'll notice that this is very similar to what we did before. Before, when we split it up into two equations, the first equation was the same as the original one, but without the absolute value symbols, and that's still true here. And then the other equation is what we get if we take the opposite of the right-hand side, which is exactly what happens here. So even though it's a different sort of a scenario with two absolute value symbols instead of one, or two pairs instead of one pair, the procedure ends up being basically the same. We split it up into two equations. We've got one equation, which is just what we get if we erase the absolute value signs. And then the other equation is the same as the first, but the right-hand side we're taking the opposite of. Now, I've gone on in talking about what we do, but now we need to actually go through and solve these equations for x. In the first one, we have variables on both sides. We can eliminate one of them by subtracting 2x from both sides of the equation. This gives us 3 equals 2x minus 3. If we add 3 to both sides, that gets the 2x term by itself. So 6 equals 2x. And then to get x alone, we need to divide by 2, which gives us 3 equals x. And then in the other equation, we have to distribute this negative sign to both of the terms inside the parentheses. When we do that, that gives us 2x plus 3 on the left, and then negative 4x plus 3 on the right, because a negative times a negative is a positive. Now again, we have variables on both sides. I'm going to add 4x to both sides to eliminate that 4x term. This gives us 6x plus 3 is equal to 3. If we subtract 3 from both sides, that gives us 6x is equal to 0. And if we divide by 6, that gives us x equals 0. So the two solutions we have for this absolute value equation are x equals 3 or x equals 0. If you plug either of those into the original absolute value equation and you evaluate, The first one, x equals 3, is going to give you the absolute value of 9 equals the absolute value of 9, which we know is true. And then if we plug in x equals 0, this is going to give us the absolute value of 3 equals the absolute value of -3, which we also know is true. So both of these end up being correct solutions to this absolute value equation.